So let's move on to our third example. Solve the equation 9 to the power of x plus 10 times 3 to the power x equals to 3 to the power x plus 2 plus 12. Oh no, Mr. Ng, this is a 4 terms exponential equation. 1, 2, 3, 4. What do we do? Don't panic. Remember I shared with you that when we deal with 3 or more terms exponential equation, the standard technique we normally try to use is simultaneous equation. So we'll stick to that strategy, okay? Let's plow through the solution together. So 9 to the power x, I can write this as 3 to the power of 2, right? Instead of writing 9, I can write it this way, right? Plus 10, then 3 to the power x equals to 3 to the power x times 3 squared plus 12. Okay, I can write it this way. So you may ask me, Mr. But why do you write 9 as base 3? Because over here, right, I notice there's 3 to the power x, there's a 3 to the power x here, right? And I realize that I can express 9 as base 3. But when I do that, over here, I can have a quadratic case later. I can have a square, right? A square appearing. So over here, if you look carefully again, instead of writing 9, right, Mr. can write as 3 squared. So this is 9 to the power x, so it's the same, right? 3 to the power x times 3 to the power of 2. Recall our laws of indices. When you multiply two expressions with the same base, what do you do with the power? Add the power, right? So 3 to the power x plus 2. 3 to the power x plus 2. That's the same. Okay, so from here, Mr. were to rewrite it. Instead of writing 3 squared, I can write 3 to the power x. Then square, okay? Not 3x, it's 3 to the power x, then I square it. Are they the same? Again, you recall our law of indices. A to the power m raised to the power n equals to a to the power of m times n. Right? So 3 to the power of x, then raised to the power of 2 is 3 to the power x times 2. X times 2 is actually 2x. So this is 3 to the power of 2x. Right? 3 to the power of 2x, over here 3 to the power of 2 is 9 to the power x. They're all the same. So plus, this is 10 to the power of 10 times 3 to the power x equals to 3 squared is 9. So 9, then 3 to the power x plus 12. Okay, so far so good. Okay, so over here, what we do is, like I said, we use a substitution method. Over here, I let y be 3 to the power x. Okay, so now I replace all the 3 to the power x with y. So over here, this is my y square. Right, this is y square plus 10, then I have a y here. Right, equals to 9, this is also y, right? Plus 12. See? Over here we have a very familiar quadratic case, right? Let's try to solve it. So y squared plus, this is bring the 9 over, so we have plus y. Okay, subtract 9 on both sides of the equation, I have a plus y over here. Minus 12 on both sides of the equation, I have my negative 12 here. This is 0. I can proceed to factorize this. So 4 and 3 plus minus. Double check. Y times y is y squared. Positive 4 times negative 3 is negative 12. 4y minus 3y is positive 1y. Correct. So from here, it tells us that y is equals to negative 4 or y is equals to 3. Okay? So can I pop the champagne and celebrate now? Yay! Not yet, right? Stop only when you find x, right? We haven't found x yet, we only found y. So let's continue. What is y? Y is actually 3 to the power x. So we have 3 to the power x equals to negative 4. But this part I already talked it in my previous example 1, right? Exponential is always positive. It can never be negative value, impossible. So this part is rejected and A. Okay, because exponential something, it can never be a negative value and never. It must always be a positive value. So we continue, or 3 to the power x equals to 3, right? 3 is the same as 3 to the power 1, right? You can equate this, make the base the same, equate the power, so x is equals to 1. There you go. So x equals to 1 is the answer to this exponential equation. Again, how do you double check in exam? So sub x equals to 1 inside to the left hand side of the equation, punch the calculator, store the value, then sub x equals 1 into the right hand side of the equation, punch the value, check whether are the two values the same or not. Okay, they must be the same. If they're the same, you know that x equals 1 is correct. It's